A great revolution in producing affordable, abundant, convenient, and clean energy so that 1 kilogram of it could supply the power of moving a machine for years. One, a new explanation for the ability of electrons to move heavy objects, create high speeds and high powers. 2. Calculating the ability of electrons to do work in consumer sources like trains, cars, planes, etc. 3. How to manufacture an electron tank and supply the necessary electrons for its tanks. A new explanation for the ability of electrons to move heavy objects, create high speeds and high powers. When we consider the physical dimension of a parameter, we can understand that it depends on which base quantities such as length, mass, etc. The presence of a base quantity in a parameter indicates the dependency of that parameter. Nowadays, it can be said that about 90% of our appliances rely on electricity. If we look at electric cars, electric trains, and other electronic appliances, we can see that they are all electron dependent. In fact, electrons are the basis of the working of such machines. Electrons have the ability to do work due to movement and displacement. It can be said that the moving electron has a high ability to do work. All we know, the speed of electron in wires is close to the speed of light. But another effective parameter that makes electron have a very high ability to perform various tasks is its density. Two, calculating the ability of electrons to do work in consumer sources like trains, cars, planes, etc. To calculate the density of an electron, we can write considering the magnitude of its density, it can be said that the ability of an electron to do work is due to its very high density. It can be said that the product of velocity in density is an effective parameter in the high ability of electrons to do work. Now we calculate the energy of n electrons to do the work. If we multiply and divide the above equation by the volume of an electron, we have To calculate the number of displaced electrons, we use the following formula. Where delta M is the mass changes of the source before and after doing the work. And M of E is the mass of one electron and equal to this number. By placing the values in the E of N equation, we have given that the speed of electron in wires is close to the speed of light, and inserting the classic amount of electron volume, we have Now, by placing the density and speed of electron to calculate the energy of 1 gram of electrons, if we want to calculate this energy for 1 kilogram of electrons, we have According to the above relations, it can be concluded that for every kilogram of electrons, a lot of energy can be obtained, which is efficient and replaceable in all cases where electricity is used. For example, consider a 2-ton car. This vehicle requires energy of about 10 to the power of 9 joules to travel 100 kilometers. Therefore, 1 kilogram of electrons can easily provide the energy needed to travel a distance more than 500,000 kilometers. or in fact can move this car for more than 3 years. Conclusion. In other words, vehicles and everything that works with this power can be charged for months and years.